Good morning, students. In the previous class, we have discussed about the complex numbers. Okay, complex numbers. In that polar form of a complex number, we have discussed what is polar form of a complex number. Any complex number can be expressed in the form of z is equals to r of cos theta plus I sin theta. R of cos theta plus I sin theta, where r is called the modulus of the complex number and theta is called the argument or amplitude of the complex number. In z is equals to r of cos theta, r of cos theta plus I sin theta. This is the polar form of the complex number. That one is the polar form of the complex number, where r is the modulus. Where r is the modulus. Where r is the modulus of the complex number. Modulus and theta is the complex, theta is the amplitude. Theta is the amplitude of the complex number. So you have to find the r value. R is equals to square root of x square plus y square, where r is equals to square root of r is nothing but modulus of z, which is equals to square root of x square plus y square. Okay, square root of x square plus y square, where theta is the amplitude or argument of the complex number. Theta is the amplitude or argument of the complex number. So it depends upon the quadrant in which it lies. So it depends upon first quadrant. If it is first quadrant, we have to write theta is equals to tan inverse of y by x. Okay. If it is in second quadrant, in the previous class we have discussed, if it is in the second quadrant, we have to write theta is equals to pi minus tan inverse of y divided by modulus of x. If it is in the second quadrant. If it is in the third quadrant, theta is equals to minus of pi minus tan inverse of modulus of y divided by x. So we have to put the bracket for both y and x. Okay. If it is theta in the fourth quadrant, so minus tan inverse of modulus of y divided by x. So these are the four quadrants in which theta lies. So it depends upon the problem. We have to substitute these values. Okay. So if it is in the fourth quadrant, we have to write theta is equals to tan inverse of y by x. And if it is in the second quadrant, this one is first quadrant. Okay. First quadrant. If it is in the second quadrant, pi minus tan inverse of y divided by modulus of x. So which is equals to second quadrant. If it is in the third quadrant, if theta lies in the third quadrant, we have to substitute this y and x value in pi. Theta is equals to minus of pi minus tan inverse of modulus of y divided by x. It is in the third quadrant. If it is in the fourth quadrant, theta is equals to minus tan inverse of modulus of y divided by x. So these are the formulas we need to understand. Okay? Then only we can write polar form of a complex number. Okay? So you should know all these things. Other than this, what we have to know, this tan values. What are the tan values? In the previous class we have discussed. I'll write here what is tan of pi by 6. Tan of pi by 6 is equals to 1 by 3. So tan 45, tan pi by 4 is equals to 1. So tan pi by 3 is equals to root 3. Tan pi by 2 is equals to infinity. So those values also you should know. Tan 1 by root 3. Tan pi by 4 is equals to 1. Tan pi by 3 is equals to root 3. And tan 90 degree is equals to infinity. To solve polar form of a complex number, we need to know this all four quadrants formula along this tan table. Okay? Then only we can solve the problems. Okay? We will continue the problems. Yesterday what we have seen the first quadrant and second quadrant problems we did, I think. Okay? So find the polar form of a complex number. So 1 minus I. So we have to find the polar form of a complex number. 1 minus I. Okay? 1 minus I. So first we need to check now in which quadrant lies. This one is plus and minus now. Plus, minus. Which quadrant? Plus and minus. We can check this. Which quadrant? Plus, minus. So it is in fourth quadrant now. Plus, minus. X-axis will be plus and y-axis will be minus. Plus, minus in fourth quadrant. Plus, plus is in second quadrant. Minus, plus. X-axis is minus. Y-axis is plus. Minus, plus is in second quadrant. Minus, minus. Because it is in minus, this is minus, plus. Second quadrant, this one is minus, minus and plus, minus. Okay. So first quadrant plus, plus. Second quadrant minus, plus. Third quadrant minus, minus. Fourth quadrant plus, minus. Okay. We should know all these things. So theta lies in fourth quadrant. What is x value? X is equals to 1. Y is equals to minus 1. So how to find r? R is equals to square root of x square plus y square. So 1 square plus of minus 1 square, which is equals to square root of 2. R is equals to square root of 2. How to find the amplitude? Theta is equals to fourth quadrant formula. So plus minus tan inverse of modulus of y, that is minus 1. So divided by x value is 1. So which is equals to minus tan inverse of modulus of 1 become plus now. So 1 divided by 1, which is equals to minus tan inverse of 1. So minus tan inverse of 1 is equals to tan inverse of 1 can be written as tan pi by 4. So minus is there, no? So minus pi by 4. So theta is equals to minus pi by 4. So r is equals to square root of 2 and theta is equals to what? Theta is equals to minus pi by 4. We have to substitute this value in here. So z is equals to, what is r value? Root of cos theta. Theta is minus pi by 4 plus I sin minus pi by 4. Okay. Minus I sin minus pi by 4. So we can write like this also. Root 2 of cos pi by 4 minus you can write here. Instead of here writing this minus here, we can write minus here. Minus pi by 4. Okay. So this one is the polar form of the complex number. So polar form of the root 2 cos pi by 4 minus I sin pi by 4 minus I sin pi by 4. This is the complex numbers polar form. Okay. Over. Next. plus minus. So excuse for that. Root 3 minus 1. So this one is plus minus no. What is x value? X is equals to root 3. Y is equals to minus 1. X is equals to root 3. Y is equals to minus 1. What is the modulus formula? R is equals to square root of x square plus y square. So R is equals to, these two will get cancelled, 3 plus 1. So R is equals to square root of 4. R is equals to 2. Plus minus is also third fourth quadrant. So theta is equals to minus tan inverse of minus 1 divided by root 3. So minus tan inverse of minus 1, modulus of minus 1 become plus 1. So 1 by root 3 is tan pi by 6. So which is equals to minus pi by 6. Minus pi by 6. So we can substitute in the polar form. Okay, we can substitute in the polar form. We will get the result. So the result is equals to r of cos theta plus phi sin theta. We will get a root 2, that is root 4 is equals to 2. 2 of cos of minus pi by 6 plus I sin of minus pi by 6. That can be also written as z is equals to 2 of cos pi by 6 minus I sin pi by 6. This one is the polar form of the complex number. Okay. Next one. Z is equals to minus 1 minus I root. So minus third. It lies in theta lies in third quadrant. Okay. So how it will be? So R is equals to square root of minus 1 whole square plus of minus root 3 whole square. Okay. This x value is minus 1. X is equals to minus 1. Y is equals to minus root 3. Okay, x is equals to minus 1, y is equals to minus root 3. So r is equals to 1 plus minus root 3 into minus root 3 is equals to plus root 9. Square root of 9 is 3. So r is equals to 2. So formula theta, third quadrant formula we have to substitute. This we have to check. Pi minus tan inverse of third quadrant. This is third quadrant. Y is minus root 3 divided by minus 1. So pi minus tan inverse of root 3 only. Okay, because minus it is going to be plus modulus sign is there. Root 3 is pi by 3. So pi minus pi by 3. So 3 pi cross multiply. Pi into 3 pi minus pi divided by 3. So 2 pi by 3. So r is equals to 2 and theta is equals to minus, and we have to put minus sign also because in the formula it is minus is there now. So minus sign we have to put. So minus of this value which is equals to theta is equals to minus, because in formula minus, because x-axis is also minus, y-axis is also negative, no? So minus of this minus 2 pi by 3. Okay. So we have to substitute in z is equals to r of cos theta plus I sin theta. We will get the result. That is equals to z is equals to 2 of cos of minus 2 pi by 3 plus I sin of minus 2 pi, minus 2 pi by 3. Okay. This is the polar form of the complex number. So this is important. For 2 marks, 3 marks it is coming in the examination. Okay. For 2 marks, see little bit simple problems will be there. And for 3 marks, root 3, minus 1, minus root 3, minus I root 3. Those kind of problems will come for 3 marks. This one is important. Repeatedly they'll ask in the examination. Okay. So if x plus I1 a plus ib divided by a minus ib, prove that a square plus b square is equals to 1. If x plus iy is equals to a plus ib divided by a minus ib, we have to prove that x square plus y square is equals to 1. So what is x plus iy? X plus iy is equals to a plus ib divided by a minus ib. Correct as equation 1. So what is the conjugate of this equation? What is the conjugate of this complex number? So x plus iy is x minus iy. A plus ib becomes a minus ib. A minus ib becomes a plus ib. Called as equation 2. You have to multiply. You have to multiply the equation 1 and 2. So how it will be? So multiply 1 and 2. So x plus iy into x minus iy is equals to a plus ib, a minus ib. You are multiplying the equation 1 and 2. So a minus ib divided by a plus ib. Okay. So what is a plus b into a minus b? A plus b into a minus b is equals to a square minus b square. So a plus b, a minus b is equals to a square minus b square. It is of this form. So a square is x square minus b square is iy square. This everything will be cancelled. The remaining term is 1. So x square minus I square value is minus 1 y square. Okay. So it implies x square minus into minus plus y square is equals to 1. X square plus y square is equals to 1. This is important question. Okay. This one is important. Okay, it is very simple. So the given equation complex number is x plus iy is equals to a plus ib divided by a minus ib. You have to take the conjugate of this x minus iy. A plus ib becomes a minus ib. A minus ib becomes a plus ib. After this, after taking the conjugate, you have to multiply equation 1 and 2. So how to multiply equation 1 and 2? This is 1, this is 2. LHS we have to multiply first. This is LHS and this one is RHS. So a plus b into a minus b. What is a plus b into a minus b? So a plus b into a minus b is a square minus b square. So RHS everything will get cancelled. We will get 1. So it is of the form a square minus b square. No, a square minus b square. A is x, b is iy, b is iy. So iy square. So x square minus into minus plus y square, which is equals to 1. Okay. This one is simple. Next, express I raised to 18 plus 1 divided by I raised to 25 in a plus ib form. This is important. Express I raised to 18 plus 1 divided by I raised to 25 in a plus ib form. So, we know the integral powers of I, right? We know the integral powers of I. I is equals to square root of minus 1. I square is equals to minus 1. If you know these two, I square value and this I, and it is very easy to find out the other values. What is I cube? I cube is equals to I square into I. I raised to 4 is I square into I square. So the integral powers of I. So I square root of minus 1. I square minus 1. I cube. I square into I. Minus 1 into I. Minus I. Right? So I4. I square into I square. So minus 1 into minus 1, which is equals to plus 1. Similarly, I raised to 4k is equals to 1. This one is the integral form of the I, integral form of I. Okay. So I is equals to square root of minus 1. I square is equals to minus 1. I cube is equals to I square into I know. So minus 1 into I, which is equals to plus I. So I raised to 4. I square into I square, which is equals to minus 1 into minus 1, which is equals to plus 1. So I raised to 4 is also 1. We can use this integral powers of I. So in the while solving these kind of problems. So I raised to 18, I can write I raised to 2 into 9 now, because there is one formula. A raised to n is equals to A raised to mn. Theory of laws of indices. Okay, laws of indices. By using that, okay, A raised to m into A raised to n is equals to A raised to m plus n. Those are the formulas. Okay, so this one is that 1 to the power of 25 is 1 itself. So we can write I raised to 25. So I square 9 plus 1 divided by, so I square, so raised to 12 we can write, 12 2s are 24, okay. So and this I, remaining is I. So there is one formula, an into an, A raised to m, A raised to n, A raised to m plus n. These are the formulas we need to know that, okay. So 12, 2 2s are 4, 2 1s are, which is I raised to 25 is there, no. I square 20, I square 12 we can do. So I raised to 1. So what is I square? Minus 1 to the power of 9 now, plus 1 divided by, I square is what? I square is minus 1 to the power of 12 into I, correct? Okay. So minus 1 to the power of 9. So minus 1 to the power of 9 is minus 1. Okay. Because if you multiply 9 times by -1, you will get minus only. Because the index is 9, the power of -1 is 9, odd number. So it is -1 plus 1 divided by -1 to the power of 12, because it is an even number, it is plus 1 only, no. So 1 into I, okay, 1 into I. Next, what will happen? So -1 plus 1 divided by I. So -1. If I take minus to the numerator, so what will happen? It is going to be minus I. So -1 plus into minus I. So the simplified form of this I raised to 18 plus 1 divided by I raised to 25. So it is in the A plus IB form, means it is conjugate form. Okay, we got it in the A plus IB form. -1 minus I. Okay. Over. Next, three plus root 2I minus root 2I divided by 5 plus 2I. 5 plus 2I minus 5 minus 2I. 5 plus 2I minus 5 minus 2I. So we have to write it in A plus IB form. We have to write this in A plus IB form. So what we have to do first? We have to multiply numerator to numerator. Then in denominator, that is subtraction of complex numbers is there. Okay. So what is A plus B into A minus B? It is of the form, no. A plus B into A minus B. What is A plus B into A minus B? Which is equals to A square minus B square. A square minus B square root 2I whole square. So divided by 5 plus 2I. You multiply by minus 5, minus into minus plus 2I. So 3 3s are 9 minus root 2, that is 2. Okay, root 2 whole square. So 2 and I square. Okay, which is equals to 5. This will cancel. 4I 9 minus 2. I square value is minus 1. So 4I. So 9 minus into minus plus. Okay, minus into minus plus 2. 4I, which is equals to 11 divided by 4I. So did we get it in now? A plus IB form? No, again we have to rationalize in the denominator. So how it will be? Minus 4I divided by minus 4I. This is the rationalizing the denominator. So 11 fours are minus 44i. So 4 fours are 16 I square. Okay. Okay. Minus 44i. So minus 16i square value is minus 1 now. Minus, we can cancel it up. Minus 44i divided by minus 16. Minus, okay, cancel, no. This is I square value is minus 1. So minus 44i, 4i, that is minus 16. So it is after this only it is plus 16. Okay, you can directly do this one here minus. So 44i divided by 16 only. So this is of the form a plus ib. So 0 plus I of 44 divided by 16. This is of a plus ib. Okay. Minus 44i divided by 4i. So this 4 4 is 16. I square value is minus 1. Okay. Next one. Find the least positive integer m. Find the least positive integer m. Find the least positive integer m such that 1 plus I 1 minus I to the 4m is equals to 1. First we need to simplify this 1 plus I, 1 minus I. So what is 1 plus I divided by 1 minus I? So we have to rationalize in the denominator. So rationalizing the denominator, we get 1 plus I divided by 1 plus I. 1 plus I divided by 1 minus I. So 1 plus I divided by 1 plus I. So which is equals to 1 plus I whole square. This is of a minus b into a plus b is a square minus b square. 1 square minus I square. So a square plus b square plus 2ab. Okay, a plus b whole square formula. 1 square is 1 minus I square is minus 1. Okay. So which is equals to 1 plus I square value is minus 1. So plus 2 into 1 into I is 2i. So 1 into minus 1 is which is equals to plus 1. So 2. So these two will be cancelled. 2i divided by 2. So which is equals to I. So what does it becomes? 1 plus I divided by 1 minus I. The value of that is equals to I. So I raised to 4m. When it will become 1? When m is equals to 1. So it will become 1. When m is equals to 1. So it is going to become 1. It is nothing but the formula is to be for a 4k is equals to 1. When m is equals to 1, that it become this I raised to 4m is equals to 1. Okay. So if x minus iy, if x minus iy is equals to square root of a minus ib divided by c minus id. If x minus ib is equals to square root of, prove that x square plus y square whole square is equals to a square plus b square c square plus d square. So we have done in the previous example. So similar to those kind of example. So what is x minus iy? X minus iy is equals to square root of a minus ib divided by c minus id. So we need to take the conjugate. What will be the conjugate? Call it as equation 1. So x plus iy conjugate we take, okay? So a plus ib, c plus id, okay? So conjugate of x minus iy is x plus iy. So conjugate of this is this. So multiply 1 and 2. Multiply 1 and 2. How it will be? So x minus iy. So x plus iy is equals to square root of a minus ib, c minus id, c minus id. So into square root of a plus ib, c plus id. So we have multiplied on this equation 1 and equation 2. So what is x minus iy into x plus iy? In the previous example we have discussed a minus b into a plus b, which is of a square minus b square. So what it will be? So x square minus iy square, it is going to be x square plus I square, no? X square plus y square. And this is also same. So a minus ib into a plus ib is a square plus b square. So this is c minus id into c plus id is c square plus b square. Okay. So if you take square root on both sides, if you take square on both sides, what it will be? So take square on both sides. So x square plus y square whole square is equals to a square plus b square c square plus d square, square root of. So taking square on both sides. So x square plus y square is equals to a square plus b square c square plus d square. So we got the proof, okay? So many examples are there, so many similar examples are there. You can sort it out. Okay? I am sending notes also. Until then, you can just practice similar problems, exercise problems. You practice it, okay? Next, find the modulus of, find the modulus of this. How to find the modulus of this? What is this denominator? 1 minus I into 1 plus I, no. Cross multiply 1 plus I into 1 plus I. 1 plus I whole square minus 1 minus I into 1 minus I. 1 minus I whole square divided by 1 minus I into 1 plus I. Okay. So this 1 plus I whole square minus 1 minus I into 1 minus I is 1 minus I whole square. So 1 minus I into 1 plus I as it is. So what is a plus b whole square formula? A square plus b square 2ab. Okay. A square plus b square plus 2ab minus a square plus b square minus 2ab. So this one is a plus b whole square, a square plus b square plus 2ab minus of a square plus b square minus 2ab. So a minus b into a plus b is a square minus b square. Okay. 1 plus I square value is minus 1 plus 2 into 1 into I is 2i. First we simplify that one. 1 square is 1, I square is minus 1 minus 2i. Okay. So which is equals to 1 minus I square value is minus 1. So 2i. Okay. These two will get cancelled now. Minus into minus plus, okay. Plus 2i, okay. See, these two will get cancelled. Minus 2i will be remaining. So minus into minus is plus 2i, which is equals to 4i. So 4i divided by 2. 2 ones are 2 twos are, which is equals to 2i. The answer is 2i. But what is the question? We have to find the modulus of this one. What is the modulus formula? We have to write it in this form first. A plus I form, where x is equals to 0, y is equals to 2. So modulus is equals to 0 square plus 2 square. So r is equals to square root of 2. 2 square, no, square root of 2 square is 4. So r is equals to 2. Because the square root of 4 is equals to 2. Okay. If 1 plus ni whole square is purely imaginary, is purely imaginary, find m. So in the beginning, in the beginning class we have discussed what is purely real and purely imaginary. So if in z is equals to x plus iy, if I substitute x is equals to 0, then the value 5. So it is purely imaginary. If y is equals to 0, then x is equals to purely real part. So we have discussed like that. So what is 1 plus ni whole square? That is a plus b whole square, no? A square plus b square plus 2ab. Okay. 1 square is 1. N square, I square, n into square, n square into I square plus 2ni. So 1 plus n square, I square that is minus 1 plus 2ni. So 1 minus n square plus 2ni. 1 minus n square minus this plus n square. Okay. 1 minus n square plus 2ni. Whatever they given, it is purely imaginary. Purely imaginary means, so we shouldn't take this, we have to take this real part. Real part is equals to 0. What is real part here? 1 minus n square is equals to 0. 1 is equals to n square. N is equals to square root of 1. So n is equals to 1. So the value of n is equals to 1. Okay? So this is also important. If you add 1 plus ni whole square is purely imaginary, find n. So it is of the form a plus b whole square. A square plus b square plus 2ab. Okay, a square plus b square plus 2ab. So 1 square, this is a square, b square, 2ab. So 1 square is 1, n square, I square plus 2 into 1 into ni is 2ni. So 1 plus n square, I square value is minus 1 plus 2ni. So 1 plus into minus minus n square plus 2ni. If it is purely, so we have to, if it is purely imaginary, then the real part will be 0. So real part is equals to 0. 1 minus n square is equals to 0. 1 is equals to n square. N is equals to square root of 1. N is equals to 1 because the root 1 is equals to 1. So okay students, similar problems you try. So we'll continue in the next session. Okay.